Asyle, Tropical Island Survival. Week 8, Day 1. It has now officially been 2 months on this island, and I'm starting to have really bad fits of loneliness again. I got them pretty much every week or so at home, but at least then I had family or other connections to dampen its effects a little. Out here, though, I'm even less likely to meet someone like myself than I was back home. I'd done the math, researched the statistics, all but given up looking for someone like me. I haven't really been writing about it because it hasn't been relevant, because I forgot, or because I didn't want to remember. But at times, it paralyzes me. I'd be in the middle of working on something and be overcome like a tidal wave with the realization that I'm alone. I'm going to die alone. My ideas will not outlive me, and there's no one to share my thoughts with. Only working on my projects helps me keep this at bay, so after conducting my morning chores, I'll return to my to-do list to help keep me sane. One of the big and hopefully exciting and distracting items on the list is to explore the cave over by the ruins. I took the lantern from the beach hut to light my path. I had no idea how extensive the caves were either, so I made some extra bamboo cord and rope to line my path and help me find my way out if my lantern failed. I also brought my survey staffs to help me map the place out as I went. When I reached the cave, I climbed over the middens and began exploring. The cave wasn't necessarily that deep or hard to map, mostly a meandering line toward the center of the island, about 50 meters long. However, it also branched off in several places, which I tried to map, but it was harder to do in the dark because I couldn't see the angles as well to confirm them. The cavern walls were relatively smooth and round, and I could see several layers of volcanic strata up them. The black volcanic rock they're made out of tells me that these were lava tubes rather than the more typical limestone caverns, created by rivers of low viscosity lava, which were effectively frozen over on the surface of the island, and then retreated when the lava pressure in the volcano dropped. As a result, I found in various layers a menagerie of mineral crystals, some of which I recognized, growing out of the rock, particularly in the terminal ends of the caves, forming veins in the layers of hardened lava. This told me, first of all, that they were likely to be metal sulfides, because down in the Earth's mantle, sulfur basically dissolves the metals that are in the magma, but don't dissolve in the magma itself, like water and oil. And when the volcano erupted, the metal sulfides, being lighter, got left behind like sea foam on a beach. I think sulfur also tends to make the magma runnier, hence the shield volcano and lava tubes. The first and easiest mineral to spot was iron pyrite, by its gold/silvery sheen. I can tell that it isn't actual gold by the cubic shape of the crystals. Real gold does not crystallize, but rather typically alloys with other metals, and separates out in bands of quartz-like minerals, which aren't out of the question of finding here either. When I struck it with my axe while trying to collect a sample, the iron pyrite produced sparks, which is how it got its name pyrite. I can use it as a fire starter instead of having to use my drill press and a piece of bark each morning. Iron and lead pyrites can also be used as diodes in simple crystal radios. This wouldn't allow me to send a rescue signal, but it might allow me to at least hear the outside world, and maybe tell if a boat or plane is approaching the island. I collected as much iron pyrite as I could, knowing that I could smelt or otherwise process it into iron tools relatively easily, and that's a game changer. The next easiest mineral to spot was copper sulfide, which formed brilliant bands of green and blue minerals, which appeared to form kind of a dripping stain leaking out of some of the bands of darker mineral crystals, particularly on or near the stalactites on the ceiling. I was also quite eager to collect these minerals, not only for tools, but for electronics if I can get enough to make wire. Other crystals were harder to identify. Many were simply dark gray or black color with various crystalline shapes, but they still had enough of a sheen or color difference from the granite walls that they caught the glint of my lantern so I could collect them. I also found samples of shiny volcanic glass, some of which looked like they might have been split from the rock already, possibly by the native Polynesians, in an attempt to make high-quality razor blades. I look forward to trying to replicate the process, as I've gotten quite shaggy in the past 2 months, and I hate having a beard. Finally, wedged inside the rocks as inclusions and sometimes scattered around them, I found small green crystals, some larger than others. I wondered if they were emeralds, but a quick scratch test told me that they were much too soft. I think emeralds are a form of silicon dioxide or quartz with various inclusions in them to change their color. These crystals, however, wore down like crayons when I scraped them across a quartz-like deposit in the wall. These must be olivine crystals, which I understand are very common in volcanic rock. I wasn't sure what they were good for, but some of the larger specimens were pretty, so I took a few samples of them as well. As I mapped out one of the offshoots of the main cave, I found it terminating in a pool of relatively concentrated sulfuric acid, with stalactites reaching down into the pool but never touching it. That and the sharp smell warned me of its contents. This reminded me of something I heard of called acid mine runoff, and it occurred to me that processing, concentrating, and refining the iron pyrite, in fact any sulfur mineral, might be easier than I thought. I may not even need to use fire if I'm willing to wait a while. I could just soak the minerals in water and allow the sulfuric acid to concentrate, as it's used industrially to refine low-grade ores. And let's face it, any ores I find on this island are probably going to be relatively low-grade. Otherwise, it would have been worth someone's time to mine it already. Probably another reason this island is largely untouched by civilization. Acid leaching should be much slower than smelting, but it could save me a lot of wood in the long run, which is getting rarer and rarer on this island. What's more, sulfuric acid can be used as an electrolyte for batteries or electrolytic cells, which I could use to accelerate my ore refining process if I could make a source of electricity. By the time I finished collecting my samples and headed back to base, it was already getting dark, as I'd lost track of time underground, gathering up all the loose mineral deposits I could carry. I was so excited that I almost forgot to collect and process the paper I set out this morning. Week 8, Day 2. I really wanted to work on processing and playing with the minerals I found yesterday, but I didn't have the light or tools to begin working on them, so I reluctantly set them aside, prepared another round of paper, had dinner, and tried to fall asleep. My head was spinning, though, with all the possibilities and logistical requirements for these metals, so as I was trying to fall asleep last night, I made up my mind that I really needed some kind of dedicated chemical lab to store and process all the compounds I'm going to make and collect, in particular the metal ores, because a lot of them I'm having difficulty identifying, and I'll need the proper tools to do so, ideally in bulk. For now, though, when I'm done with my morning chores, I'll simply set them to leach in a pot of distilled water and start thinking about how I want to make this lab. They're going to take forever to leach anyway. I decided to model the lab after the kitchen for the most part, cylindrical with counters around the circumference, and using my old kiln as a distiller and hot plate for chemical reactions. One of the key features that distinguishes this hut from the kitchen is ventilation. I would ordinarily want the building to hold in the cold of the night for me all day, but in this case, I won't always know what kind of vapors will be produced by my chemical experiments, and they may be toxic, so I'll need some way of channeling the wind into the hut. I kicked around a few ideas, from building funnels onto the windows or near the floor, to a giant venturi tube on the roof. I finally decided, however, that the simplest solution would probably be to put some kind of wind turbine on the roof and let it spin a fan on the ceiling. By putting vents near the floor or the counters, this should create a mostly laminar airflow up and out of the hut. The precision placement of these vents will make lighting a problem, though, since I can't have windows all over the place messing up the airflow, However, if I make the hat on the central skylight high enough, I should get plenty of light through there. In order to do this and create the necessary structural integrity to hold the turbine up, the roof of this hut will need to be more of a cone than a dome. This will also require tension struts in the ceiling, but that's okay, because they'll also give me a place to mount the fan bearings and hang the lamps. At least I won't have to dig another cellar for this one, and I have plenty of dirt left over from excavating the ruins the other day, even if it's a short hike away. With a plan in place, I got to work, starting with cutting down and weaving bamboo for the frame. As I mentioned, the roof needs to taper to a point. As I built the framework, I tied in spokes near the top to hold in the ceiling fan later, in addition to those which will be used to make the counters. No frames for windows, just narrow vents near the floor and countertops to direct airflow, a large frame for the door, and a vented alcove for the small distillation kiln. This only took a couple of hours. I find I'm actually looking forward to another big construction project after the big destruction project last week. After lunch, I decided to begin collecting the clay I'm going to need for the dig site. I took a moment to estimate how long it would take me to cart all that dirt around first, though. The lab has about the same dimensions as the kitchen, about 100 cubic feet, and my wheelbarrow has a carrying capacity of about 6 cubic feet. If it takes me about 5 minutes to snake through the jungle to the dig site and another 5 minutes to walk back with my load, that's only 0.6 cubic feet of dirt per minute, not counting the time I'd spend loading it in. So I concluded it would actually be faster for me to just dig it up on site. At least that way I don't have to worry about accidentally mixing artifacts in with my clay. So I started digging into the floor of the lab, realizing as I went that the depression would be an excellent way to contain any chemical spills. I dug a shallow slope from the edges of the floor to a small pit I dug in the center and placed a clay pot into, so I can recover any spills in the future. I found that the floor depression didn't have to be very deep for me to get most of the clay I needed, no more than 1 foot, especially because I got the rest from digging a trough around the outside to protect the building from flooding. This was a particular concern because of the ventilation grates right next to the floor. The whole process must have taken me another 3 or 4 hours. Having spent so much of the day, and last week honestly, in the dirt, I decided to take a shower at the end of the day before prepping another batch of paper, having dinner, and getting ready for bed. Week 8, Day 3. After doing my morning chores, I got back to the construction of the lab, this time beginning work on the interior. I figured I might as well start on the largest and most complicated element first, namely the exhaust fan. I collected some bamboo and harakeke and began construction of the fan blades. I found that I could take 2 lengths of bamboo, affix their ends to each other, and tie a cord between them to keep them under tension, like 2 bows sharing the same string. Then, by twisting this assembly, I could create 2 opposing leaf-shaped frames for the fan blades, which I wove harakeke into to make the blades both light and impenetrable to air. I figured 4 blades would be enough. Now I should begin construction of the wind turbine to drive the fan, and there are many designs I'm considering for this. I figure the easiest thing to make would be a turbine that is coaxial with the fan, which will require the blades to function kind of like a paddle wheel in the air. However, to make sure that air pushes it in only one direction, the blades will need to be angled or curved relative to their axis of rotation, so that the paddle wheel always turns the same direction, regardless of what direction the wind is blowing. This is very similar to the design of the exhaust fans in bathrooms back home, which take the steam from the shower away. If I design it right, I could actually funnel the air that the fan blades are pumping up into the turbine to help push it along. The problem I have with this design, however, is that it has a very small surface area. Only half of the vertical cross-section of the turbine would be contributing to rotation, and it would inevitably be on a short lever arm, meaning that it wouldn't get a lot of torque to drive the fan blades in the first place, especially when there isn't a lot of wind. The alternative is to create more cup-shaped paddles on long arms, which can turn a small breeze into a larger force at the axis, though at slower speeds. I could try using both, but the problem with that is that the two turbines would fight against each other at the same wind speed. V equals r times omega. Velocity equals radius times angular velocity, meaning that for the same wind speed, each turbine with a different radius will try to push the axis at a different angular velocity. Eventually, I decided over lunch to go with the long-armed turbine, because it will ultimately have greater versatility in addition to being easier to build. I then got some long pieces of bamboo and wove paddles onto them. At first I was planning on just making some cups on the ends, but those would have a small surface area and would have collected less force. So as I was working, I got a better idea, where I simply made woven panels that hung from the arms of the turbine, working kind of like an airplane wing. By putting just a little tension on them to pull them into a vertical orientation, I was able to make the panels change their angle of attack based on airspeed, so the mechanism won't be over-torqued in a windstorm, and will more or less always rotate at the same speed regardless of the speed of the wind. Furthermore, because the panels are flexible, they can even change their angle of attack as a function of their radial distance from the axle, so they don't end up imparting drag to the system. The ribbed panels remind me of bat wings or turn-of-the-century attempts at flying machines, like those emulated in some Studio Ghibli films, and this accidental stylization leaves me quite tickled. Constructing the turbine took longer than I expected, leaving me without time to install it at the end of the day. I need to do this right, so I'll leave it alone for the night instead of spending the last hour of daylight working on building the bearings. Part of the trick with the bearings I needed to make was that they needed to support the weight of the turbine and fan, but without obstructing the oculus at the top of the building, so air will be able to flow out. To deal with this, I planned to build the bearings into the ring of the oculus itself, with the turbine resting on a circular race sitting on top of the bearings. This way, the weight of the turbine will be transferred directly to the structure. I chopped some short sticks and used the lathe to make them smooth and slightly tapered, which was essential for the functioning of this bearing design. I then split a piece of bamboo and tried to bend it into a circle to make the races, but the diameter was too small to bend them without breaking them. To fix this, I decided to soak the bamboo in water overnight to make it flexible. I can then bend it into the right shape tomorrow morning and leave it out to dry so it holds that shape when I install it. Besides that, all the turbine parts should be ready now, so now that it's dark, I'll start another batch of paper, have dinner, and go to bed. Week 8, Day 4. I was excited to install the turbine today, and hopefully finish most of the lab interior. So once I finished my morning chores and twisted my softened race into shape, I grabbed my ladder and got to work. I took the long bamboo shaft and put holes in it at appropriate points to install the turbine and fan blades before threading it through the oculus, where I also installed the bearing. I also tied some cords to the top of the axle, which extended a distance above the roof, and tied the opposite ends of the cords to the turbine blades for support once I'd installed them into the axle, and rested them on top of the upper bearing race. I had to tie the turbine blades down so they wouldn't turn in the wind while I finished the installation. I then went inside and installed the fan blades onto the axle, which threaded the spokes I had constructed earlier. I realized at this point that I forgot to make a vertical bearing to keep the axle straight, so I stopped work on that, though all it took was smoothing down a couple of bamboo segments and splitting a few more to make an outside race, which wasn't as much trouble as bending the one on the roof for some reason. Once I had fixed this to the spokes around the fan blades, the turbine was more or less complete, so I let it go to see how well it ran. The breeze felt pretty good, though it occurred to me that I would need a way to easily turn it on and off and to control its speed. I thought the best way to do this would be with some kind of flyball governor. A flyball governor is basically a couple of weights on the end of a shaft that are attached to a brake and get spun around. Centrifugal force drives them out from the axis of rotation, and the further out they fly, the harder they press on the brake. This wasn't a difficult mechanism to build, just a little tricky to balance. I decided to use a couple of empty coconut shells partially filled with sand as my weights, which I easily affixed to some short sticks and jointed to a rod with cord. I then jointed a couple more sticks to the weights and a short bamboo collar, such that when the governor spins, it'll push the collar up against the vertical bearing, which will apply a braking force to the axle. Finally, to make the speed adjustable, I used a little cord and a stick acting as a knob to adjust the tension pulling down on the weights. The greater the tension, the harder the weights will need to pull up to counteract it, and thus the faster the fan will be allowed to spin. At this point, I stopped to have lunch, extremely pleased with my mechanical innovations. All I really needed to do next was finish weaving a little bamboo for the countertops and shelves, and fill them in with clay like in the kitchen, which didn't take more than a couple of hours. They weren't quite dry enough to support anything when I finished them, but I still took time to move my various pots and jars of chemicals inside anyway, in addition to moving my small distillation kiln again, hopefully for the last time. I was kind of surprised that I had some time to kill at the end of the day, so as I looked around for any additional finishing touches that needed to be done, I realized I completely forgot to add a door, so I got some bamboo and took an hour or so to weave it and affix it to the frame. With my last hour of daylight, I decided to just whip up a stool for me to sit on while doing chemistry experiments, since the other things I wanted to make for the lab were a bit fiddly and would take too long. I left a fire going in the distiller to help speed along the drying of the walls and countertops, and then did my paper chores before having dinner and getting ready for bed. Week 8, Day 5. When I got up in the morning and started doing my morning chores, it was raining a little, which at first I didn't think anything of, but then realized I'd forgotten to build a hat over the oculus of the lab. It wasn't critical, just annoying. I turned on the fan to help blow out the incoming rain a little, and used some spare bamboo and bamboo leaves to build a quick and dirty hat, which I slid onto the axle of the fan apparatus. This required me to untie the turbine supports first, and to be very careful not to fall off the roof, which had become slippery from the rain. This was an annoying start to the day, but it did give me the thought that I need to make rain gear at some point. I put it on my to-do list. After completing that task and avoiding serious injury, I got back to my chores. Because of the rain, I had to dry my paper indoors. Now that I'm finished, I can begin work on some of the equipment I'll need to finish the chemical lab. There are a few things I need to know in order to conduct chemical reactions properly. Principally, I need to know how much of each reactant I have, which means I need to be able to measure weight and volume. Fortunately, I already have a little experience with this from back home. I started by making a simple scale, taking a piece of bamboo and finding its balance point as closely as I could before making a nick in the bamboo at that point. Then by supporting it there by hanging it on a thin cord from one of the lab shelves, I was able to minimize friction as a factor contributing to errors in future measurements. To make sure it was level, I hung a plumb bob from a string and attached a thin, light stick to the scale collinear to it. Now, by lining up the stick with the plumb bob, I can know that the scale is perfectly level. I took some time to shave off tiny slivers of wood from the shaft to make sure it sat as close to level as possible before putting anything on it. Next, in the absence of more sophisticated containers, I chopped some pieces of bamboo into little cups, which I suspended from each side of my scale and shaved some more to make sure they were the exact same weight. I then used my measuring tape to mark increments onto the scale. By changing the positions of the cups, I can weigh larger or smaller objects than I have weights for, because I can use the length of the lever arm to effectively multiply or divide the gravitational force balancing the scale out. This then brought up the subject of objective weights, which I knew would be hard to make here. I knew that pure water has a density of 1 gram per milliliter, and 1 milliliter is 1 cubic centimeter, So I used my measuring tape to calculate the interior volume of one of my bamboo cups as accurately as I could, and used my lathe to make sure it was perfectly smooth and consistent in shape. At first I thought water absorption into the wood might be a problem if I let it sit for too long, but then I remembered the mass would remain the same whether the wood absorbed the water or not, so I didn't have to worry about it. I then filled the tube with exactly 1 milliliter of water and filled another tube with sand until they balanced out. I now had a perfect 1 gram weight, which wouldn't evaporate over time, which I also plugged to keep the sand from ever spilling out. I then used the 1 gram weight to produce 10 and 100 gram weights, which should be all I really need, since I can functionally amplify their weights by sliding them back and forth on the scale. Next, for volume, what I would have really liked was some kind of graduated cylinder, but I couldn't really make one that was see-through with the materials I had. I thought about blowing glass, but I was concerned that I couldn't make a tube with a consistent diameter for making measurements with. I doubted I could make a fire hot enough to melt glass anyway. I decided to just settle with making some measuring cups for the time being. While I could have easily and quickly made them out of bamboo, I was concerned that they would soak up or react with any solutions I needed to measure, so I decided to make my measuring cups out of clay instead. The 1 milliliter measure, which honestly looked more like a teaspoon, I used a stick lathed down to the right shape as a form. I made it just a little bigger than I needed it to be, in case it shrank when firing, figuring that if it turned out too big, I could just grind it down a little or not fill it to the brim. For the larger 10 and 100 milliliter measuring cups, which turned out more like clay beakers, I used my measuring tape and the potting wheel to get the dimensions as close as I could. I left them drying next to the fire for the rest of the day and stopped for lunch. The lab is more or less finished, and I've already got some ideas for what to start doing with it. First and foremost, I want to nail down the recipe for vulcanizing rubber. I know that it requires the addition of sulfur, but I don't know how much, and I know that they use accelerants in the industry, but I don't know what they are or how to make them. I decided that I need to just try everything, so first, I climbed up to the caldera to collect more sulfur. When I got back, I decanted amounts of latex from my now significant supply, and used my scale to mix in increasingly high concentrations of sulfur powder, up to 10% sulfur by mass. I had to use a couple of rocks and a clay pot for grinding, which reminded me that I needed to make a proper mortar and pestle. Next, I thought I might need to cook them to speed up the reaction, but I wasn't entirely sure, so I further subdivided each sulfur concentration batch into batches for different temperatures. One set I left at ambient temperatures, one set I left in a bowl of water, which I knew would never exceed boiling temperature, and the others I put in bowls directly in the fire, though I didn't know how hot that would actually make them. This reminded me that I needed to make some kind of thermometer as well, for more accurate future experiments. Finally, I didn't know how long to cook each batch, so I decided to just check on them about every hour until I go to bed. I thought about using my beachside sundial for that, but then remembered it was raining, so the sun wouldn't cast a shadow for the sundial to read. I'll just have to guess the time, but it makes me realize now that I need a clock for future time measurements. In any case, I started a fire in the kiln and let the different latex mixtures cook. In the meantime, I decided to make that mortar and pestle. I turned some clay on the potting wheel for the mortar, and stuck a wad of clay onto the end of a piece of bamboo for the pestle. I left them in front of the kiln to dry, and I'll try to turn them every hour when I go to check on the rubber. I considered making an hourglass for a timer, and using ethanol in a small tube for a thermometer, but without glass, I couldn't really read them accurately, and I don't want to try glass blowing right now. While I looked for something to do, particularly to make sure the lab was finished, I noticed that the coconuts I set aside to replace the trees I cut down had finally started to sprout. On the one hand, it reminded me of just how long I've been here, but on the other, it's kind of a hopeful sign that I've gotten myself into a sustainable position. I decided to spend an hour or so planting them in various places along the beach, which is their natural habitat. This got me thinking about what sorts of plants I should grow in proximity to the lab, but the only ones I could think of that would be of any use for its function would be breadfruit or fig trees for more latex. By this time, it was starting to get dark anyway, so I collected my paper and started working on a new batch, checking the rubber as I went, before pulling out the last batch after dinner. I'll do some strength testing on them tomorrow. Week 8, Day 6. After my morning chores, including getting the mortar and pestle fired, I began the stress test on my pieces of rubber. I woke up feeling a bit down this morning, so this made me feel better, because it's some real engineering work. More than I ever got to do back home anyway. First, I cut the pieces of rubber into strips of identical diameters, or at least as close to identical as I could measure. Then, I tied a small piece of bamboo or coconut shell to them and filled it with sand until the strips broke. Then I measured how much sand it took to break each strip, did a little math, and calculated the tensile strength of each mixture, noting the results in my journal along with any other potentially useful observations. Firstly, I found that cooking them had a major impact on vulcanization, as the rubber I left out on the countertop was hardly any different from the control, a piece of uncut latex. The boiled rubber was better, but the cooked rubber was the best, even though it kind of burnt in a few places, inevitable under such uncontrolled conditions. However, I also noticed that some of the cooked strips were still a little gooey in the middle, which told me they weren't getting cooked all the way through, which forced me to adjust my calculations to get an accurate tensile strength. Cooking time was also an important factor, the strongest strips being the ones I'd left to cook for nearly 6 hours. Finally, I found the sulfur concentration factor was a bit of a mixed bag. It definitely helped stabilize the latex from degrading into a sticky mess, but the lower concentrations of sulfur, around 1%, resulted in strips that were soft and stretchy like rubber bands, while the higher concentrations of sulfur, around 10%, were hard and strong like car tires. Ultimately, I guess this tells me what I wanted to know. With that in mind, I'd like to take a little time to think about what I'd like to do with this knowledge. I took inventory and noticed a few of my regular pieces of equipment were starting to get worn out, particularly my shoes, clothes, and sleeping mat. I've wanted to make more comfortable clothing for a while, but I'm not going to be able to do anything about that until I can get a good fiber source and build a loom. What I can do right now with the rubber, however, is make better shoes, like proper rain boots. My mattress has also started to wear out, and I'm getting tired of having to constantly refluff it with dried grass. I considered filling it with chicken feathers, but was concerned that they might have mites or fleas in them, which could give me diseases. I remember wishing weeks back that I had an inflatable mattress, but now that I have some rubber, I might be able to make one of my own. There's one more thing I'd like to try doing with the rubber, however, and that's to make a rubber belt that I can use to build a Van de Graaff generator, which I can hopefully use to accelerate the leaching of my metal ores via electrolysis. Next, I should think about which of these projects will take the longest to build, or provide the best long-term gains the sooner I start it. While the Van de Graaff generator fits the latter criteria best, I feel like it's going to take a lot more fiddling to get just right before the weekend. After an early lunch, I decided to do some experiments and tests to start working on the boots and mattress. First, I had to figure out whether or not to make the inflatable mattress as one contiguous sheet, like some long balloon, or make it in several sheets and adhere them together. I at least knew the balloon wouldn't rip along a seam, so I used some of the rubber to experiment with making a few small strips and gluing them together with various things like resin, more latex, and stitching, to test which will be strong enough, if any. While I was working on that, it also crossed my mind that I might be able to fluff up the rubber somehow to make something like an honest-to-goodness memory foam mattress, like the one I had back home. Though that might have been a stretch, pardon the pun. I just needed to figure out how to turn the latex into a foam. I fell back on my knowledge of baking for this one. There are two ways to make a fluffy sponge for a cake. You can use a chemical reaction that produces gas bubbles, or you can whip air into it. I decided to give both a try, adding a little calcium carbonate powder to one small batch of latex, before mixing in the vinegar to make it set. I then knocked up a quick paddle from wood, attached it to the shaft of my drill press, and put another batch of rubber in a small pot with a little vinegar, before immediately using my drill press like an egg beater to see if I can integrate air bubbles into the rubber before it could set. I didn't bother adding any sulfur to this mix or cooking it because I wanted it to be soft and springy rather than tough and hard. This method actually worked a lot better than I anticipated, the stickiness of the latex easily allowing it to form very small bubbles and turn into a foam, which I poured out in the sun to dry and test later. Next, I decided to start making the boots. And while on the one hand I've always wanted to make my own shoes because the ones I buy at the store never fit right, on the other hand I quickly realized how hard that is to do because I barely even knew where to begin. The best thing I could think of was to make the soles of the shoes, which would separate me from the ground and all its hazards. I mixed up some clay to make a mold, using my feet as guides. I then made some small marks in the bottom of the depression to make treads for traction, and laid small sticks in the molds for reinforcement, and to minimize the amount of rubber that would be needed while still allowing the soles to be flexible, much like the sandals I've been wearing so far. The next factor was that these soles would have to be tough, so when I mixed up the latex, I used the higher concentration of sulfur and charcoal for maximum strength. I dusted the molds with clay powder to keep the rubber from sticking, filled up the molds, and stuck them in with the mortar and pestle to cook, keeping an eye on them so they wouldn't melt. What I forgot to factor in, however, was the molds cracking, but fortunately for me, by the time that happened, the rubber was mostly solid. It just meant I couldn't use the molds to make another set of soles in the future, but hopefully I won't need to. Working on the soles of the shoes gave me an idea for something else. I made a couple more clay imprints of my feet, but then used some more clay to create a pair of negatives, which I used as molds for another thin round of latex, which I also didn't bother to vulcanize because I wanted to use this to create a soft insole for my shoes, specific to the shape of my feet, to maximize the distribution of force across their surface and thus minimize damage. Next, I decided to work on making the actual shoe part of the shoe, beginning with using a clay mold and negative to get a rough idea of the shape of my feet, though this negative was easily deformed because the clay was still soft. That was alright though, because I didn't want the shoe to perfectly conform to the shape of my feet anyway, otherwise it would have been a big, uncomfortable rubber sock. I added clay until I had a nice shoe shape, and then mixed up another batch of high-strength latex, again because I wanted the outside of my shoes to be strong, painting a thin coating on the outside of these molds to create a sort of rubber sock around them. As this rubber set, I wrapped them in bamboo cord to give them some fiber reinforcement, both to resist cuts and to give them the strength to stay stuck to the soles later. I then painted another layer of high-strength rubber mix over them to seal the fibers in and set them in the kiln to cook, keeping an extra close eye on these ones since the thinness of this rubber would make it burn easily. I didn't want to leave the rubber unattended for too long while it was cooking, so I watched it while I ate an early dinner. After playing in the mud all day, I wanted to take a shower, but again, I didn't want the rubber to burn while I was away. When it got dark, I brought most of my paper processing stuff into the lab with me so I could continue to keep an eye on the rubber. The only exception to this was when I needed to grind down more vegetable material, but fortunately that didn't require a lot of oversight, so I could just set the millstones grinding and come back to check on them periodically between watching the latex. By about bedtime, the boot components seemed to be finished. I'm excited to try them on, but they're going to need time to cool, so I'll have to get to that tomorrow. Week 8, Day 7. It's my day off, though honestly I probably won't end up doing anything I wouldn't do on a regular day anyway, other than strenuous activities. After my morning chores, I got ready to finally assemble my boots. I was going to make some bamboo cord straps to hold the shoe to the sole, but then I realized I could just heat the rubber until it started to melt and glue them together. I did so, heating a flat stone in the fire and then pressing it against the rubber pieces until they melted. I then pressed the sticky pieces together, and it didn't take long for them to cool down and set into a single piece. Finally, I installed the insoles and tried them on. I'd never heard feet sing before, but it felt like they were now. As I paced back and forth with them, as one does when trying to wear in new shoes, I recognized a few spots where the rubber was going to wear on my bare feet, so I cut some pieces off the rubber foam I made the other day and used it to line the inside of the shoe, again using heat to glue the rubber to the insides of the shoe. I realized this could also help to wick away moisture and keep my feet from becoming moist, which can lead to blisters or fungal infections. Oh, my feet are insanely comfortable. My rubber mattress experiments from yesterday have also finished, and the rubber envelopes didn't hold air pressure very well. They were more like discount whoopee cushions. The chemical reaction foam didn't work well either. I think the calcium carbonate stealing ions from the acid prevented the latex from really setting in the first place. To my surprise, the latex sponge cake method worked the best out of all three. I still had a little of the rubber foam left over, and I realized that I could use it as a sponge for washing. There were probably natural sponges out in the reef that I could have used for the same purpose, but this way I don't have to kill anything. Double bonus. That reminded me of how much I want to shower today, but there's one thing I want to do first. The next task I set for myself was to make some obsidian blades for shaving, and to hopefully give my poor pocket knife a rest. I remembered from watching documentaries on Mesoamerican cultures that they would chip a piece of obsidian into a sort of corn cob shape, and then use an instrument that they pulled on with their feet and arms to flake off one blade at a time. I didn't want to try chipping my piece of volcanic glass because I figured I was more likely to shatter the whole thing, so I took an extra long time grinding it down on the grindstone until it was about the shape I remembered. I then used my drill press with a small stone point attached to the end to gently apply a point pressure to the edge of the cob. For a long time, all I could do was break off larger chips of the improper shape, but each break gave me an idea of what I was doing wrong and what I needed to adjust. Part of it was probably just the shape of the cob itself, but eventually I got it right and started producing proper razor blades. I only made as many as I thought I might need, keeping the cob so I could make as many blades as I want when I need them. I used my broom to brush away the useless glass chips, because I didn't want to risk cutting my feet, though that also reminded me of how thankful I was for my new boots. Once I had some blades that struck me as appropriate for shaving, I got a coconut shell full of water and used it as a mirror out in the sun to help me shave. I had to be careful not to cut myself, something I always hated about traditional razors, and why I always opted for an electric one. No such choice here, though. I kind of had to pull on my facial hairs and scrape them away with the razor blade, which I recognized would require me to wait until I grew in another beard before I could shave again. So I took a piece of bamboo and chipped off part of the edge where I could slide one of the razor blades in to create a safety razor, holding everything together with bamboo cord. It took a little fiddling to get the blade in just the right position, and the gap in the bamboo just the right size so that my skin would bulge into it close enough to the blade to cut the hair, but not close enough to cut my face. But eventually, I got it right, and added a handle to the razor for easy handling before giving myself a nice close shave. It feels so good to be smooth again. Oh, this is turning into a good day. I then took a long-awaited shower and had lunch. I'd been having so much fun making comfortable things today that I'd almost forgotten to eat. I've got a couple more hours before the end of the day, so I'd like to take some time to think about what I want to do next. I've got a lot of latex stockpiled at this point, so even though it's probably not going to be done till tomorrow, I think I'll start working on that foam mattress I wanted. I started by creating a mold, but for something this big, that basically meant digging a hole and lining it with clay, about 3 feet by 6 feet by half a foot, a volume of 9 cubic feet or 255 liters. That was a lot more rubber than I had, but because I was going to be fluffing it, it was going to end up being mostly air, up to 10 times less dense than solid rubber, so I had about enough. Once I dug the hole, I started fluffing and dumping each bowl of fluff into the mold as I went, which took most of the remainder of the day. As it started getting dark and I collected my paper for processing, I worried that it might rain on my mattress while it was drying, so I grabbed some palm fronds and other vegetation to keep it covered. I then finished my paper processing and got ready for bed. Blooper Reel. It has now been officially 2 months, which were effectively frozen, like sea foam on the beach. This wouldn't allow me to send a but in this case, I won't always know what kind of vapors. Furthermore, because the panable bananables, which I evilly affixed to some 1 gram per millimeter, 1 gram per 1 gram per milliliter. What's a milliliter? It's just a little liter. 1 gram per mill. Next for volume, what I would next. So I further subdivide so the sun wouldn't cast a shadow for the sun. So the sun wouldn't cast a sun. Hard to beat a drink of something brown. Excuse me. Oxygen seems to be getting a bit thin in here. I think I need to open a window. But that might have been a stretch. And to give them the strength to stay stuck to the soles later. Yeesh. That's a tongue twister. Oh, my feet are insanely comfortable. Double bonus. Double bonus. Double bonus. Oh, this is turning into a good day. Hey there, you made it all the way to the end. Thanks for listening. I'm planning on making a new video/audio segment every week for the foreseeable future, concurrent with my stay on the island, assuming I don't blow myself up with any of my upcoming chemistry experiments. So, if you like this and want to listen to the next one as soon as it's finished precipitating out a solution, you can press the subscribe and bell buttons under the video to get notified as soon as it's ready. Now, I'm not planning on trying to turn these videos into gold like some kind of medieval alchemist, but it would still help me out more than anything else if you could share this video with someone who you think would enjoy it. And since you apparently liked it enough to watch all the way to the end, thanks for that, by the way, it's literally the best thing you can do for me. There's a like button under the video that undergoes a color changing reaction when you click on it. Hey, am I wrong? There's also a dislike button you can press if you want, but because it has such a high pH, it won't do much. Like a lot of the chemical reactions I've been doing so far, it's pretty basic. Also, if you'd like to chat about your own stories and perspectives on the episode, like a clever chemistry experiment or project you've done in the near or distant past that you had fun with or were particularly proud of, feel free to write them in the comments section below. I welcome suggestions, corrections, and especially more bad chemistry puns. That said, thanks again for listening, and hope to see you here again next week.